We are going to cover how is it that we can graph linear inequalities and determine the possible solutions. So for that we have a first example right here. Y is less than negative 3x plus 5. The first things that we're going to focus is what is the slope and the y-intercept of my inequality. And for that we must remember our slope-intercept form. Y equals mx plus b. Now we know that here we have an equals and this is an inequality, but that doesn't matter. What we need to focus is m is my slope and b is the y-intercept. So in this case, when they asked me for the slope, I said my slope is negative 3. And when it comes to my y-intercept, in this case, is 5. So b equals 5. Okay. So for us to determine slope, y-intercept, we use slope-intercept form. But now we are being asked what kind of line and what type of shading we're going to have. For that, we go straight to the sign. In this case, my y is alone, and the less than part of the sign is pointing to the y. So I can say that my line, well, my shade first is going to go under. Why under? Because y is less. Now what kind of line is this going to be? Let's look at our symbol. Our symbol is a less than. There's no line under, so there's no equal. Every time that happens, every time there's not a line under, because the possibility of or equal is not there, we have a dotted line. Okay. Now that we know what's going to be our slope, what's going to be our y-intercept, what kind of line we're going to use, and how are we going to shade, we're ready to start graphing. We are going to start with the y-intercept. The y-intercept is 5. So I'm going to go to my y-axis at 5 right here. And that's where I start. From here, I'm going to follow my slope. Negative 3. That means that we're going to go 3 down. And let's not forget that every whole number has a 1 on the bottom, because slope is rise over run. So we're going to go 3 down, 1, 2, 3, and then 1 to the right. And this will be our second point. Now we can keep doing this, 3 down, 1 to the right, so we can keep getting more points. So when we connect them, we have a better line. Now, how are we going to connect them? Let's not forget that we said that our line was going to be dotted. So I'm going to use a dotted line to connect these points, like this. Still a straight line because it's a linear function. And let's not forget this keeps going. But in this case, it's just a dotted line. Okay. Now we're ready to shade. And we said that since y is less than, we're going to shade under the line. So that means that in this case, we're going to shade under right here. If you guys have problems knowing what is on top and what is on the bottom, so you remember going up, down. Oh, this is above, and as soon as you pass it, this is under. Always, that's the way you can figure it out. Okay, so now we're going to focus on the next part, which is what? Determine what can be a solution. So we are going to start with this point right here. Okay, the point 2, negative 1. So 2, negative 1 is this point right here. This point right here. Now this point is on a dotted line. And when a point is on a dotted line, that means that this is not a solution. That's actually what the dotted line means. It's just the boundary, not that those are going to be part of the solution. Let's go to the next one. 5, 0. And 5, 0 is 5, 0. So right here. Now this point is not in a shaded area, so we can say this is not a solution. Our last point for this example is negative 3, 1. Now negative 3, 1, this is going to be negative 3 and then 1. So right here. This point is in the shaded area, therefore this point is a solution. Very well. So remember, dotted line is not a solution, only shaded area and solid lines. So let's go to our next example. Here we have a different type of example. We have 2y minus 10x is less or equal than 18. And again, we're going to start trying to figure out what is the slope, what is the y-intercept. So we need to start again with y equals mx plus b. And here's where we're going to find our first problem, because this does not look like that. I know there's this inequality, but the y is not alone. So that's going to be our first step. We're going to take our inequality, 2y minus 10x less or equal than 18. And we are going to have to isolate y. Leave the y alone. Okay? How are you going to do that? Well, solving. We need to cancel the 2. We need to cancel the 10x, but the 10x goes first. It has to be first. So I add 10x and I do it to the other side. So those x's are going to cancel. Now I have 2y. And then I have 10x plus 18. And we haven't done anything to flip our symbol, so it's going to stay like that. Last step, cancel the 2. So we divide everything by 2. Okay, so 10 divided by 2 is 5x. 18 divided by 2 is 9. And again, we didn't do anything to change our symbol, so it's going to stay like this. So this is actually the inequality we're going to solve. This is going to be a lot easier for us to figure out. Why? Because I can see that b is going to be the 9. So if you want to see it this way, we can see that this actually became, or it transformed into y less than equal 5x plus 9. So my y-intercept is 9. And my slope is 5. Okay. Very good. Now we can start graphing. We're going to start with our y-intercept, 9. So that means that I'm going to go to y9 right here. And from here, I'm going to follow my slope, which is 5. Which means that I'm supposed to go 5 up, 1 over. Do not forget about the over 1 here. Okay? This is going to be difficult because we run out of space. So how can we graph this? There's another way. If I'm supposed to go 5 up, I can go 5 down. But if I'm going to do the opposite, instead of going up, going down, I need to also do the opposite in the run. So instead of going right, we're going to go left. So we're going to do opposite. So instead of up, down, so we're going to do 5 down. 1, 2, 3, 4, 5. And then instead of, I have 1 to the right, but I'm going to do the opposite. So it'll be 1 to the left. which is going to place me right here. And then we can do that again. 5 down, 1, 2, 3, 4, 5, and then 1 to the left. Right there. Okay. So we are ready to connect. But what kind of line are we supposed to use? Look at this. We have a line under. What does that tell me? This is going to be a solid line. Okay, so I'm going to use a solid line to connect. So we're going to connect our points as straight as possible. Let's have another point right here. There we go. There we go. There's my solid. Next step, I need to know where to shade. And this says the y is less than, which tells me that I'm going to shade under. So I'm shading under my line. Oh, this is shaded. Very good. If you want to check what is top, what is bottom, remember, upside down, this is the top, this is the bottom. Okay, let's start checking for our solutions. Let's start checking for our points. The first one that we have is -3, 2. So that means that we're going to go -3 and then 2 up. The point is right here. Is this a solution? No, because it's not in the shaded area. Very good. Now, our second point, 4, -1. So that means that we're going to go 4, 1, 2, 3, 4, and then -1 right here. Now, this isn't in the shaded area. This is a solution. So, yes. The last one, -3, -6. So, -3, 1, 2, 3, and then -6, 2, 3, 4, 5, 6 is this point right here, which is right on the solid line. And when the point is on the solid line, it is part of your solution. So yes, only dotted lines are not solutions, okay? So if for a solution, it's either shaded area or solid line.